Good morning, guys. This is Mrs. Hargrave, and this is our first video. It is over 2.1, or sorry, 2.2, not 2.1. That is the scientific measurement or method. We're going over units of measurement, and so we're going to go through a couple of things. I've made my notes nice and colorful, and hopefully you can see everything nicely. I have examples, and so this is mostly to show you how to do the mathematical side of what we're doing next, okay? So here we've got our definition. Measurements represent quantities. A quantity or an example would be, something that has magnitude, size, amount. And then I have some examples. You have a teaspoon would be a unit of measurement. A volume would be a quantity, okay? You use teaspoons to measure out certain volumes, okay? All of these measurements come from the SI system. I believe it's French. I'm not even going to try to pronounce it. But it's basically so that we could have a universal measurement system. So everyone uses the same thing and understands the same thing. Americans and a few other countries, we like to be rebels, and so we follow the English system, but it's basically the metric system is that SI system of measurement. So meters, liters, grams, those kinds of things. All right, I have in brown that you guys should look at figures 2.1 and 2.2, and I have the page numbers listed beside those. I would copy those down. Know those points of information. That would help you to figure things out quickly, okay? By probably a month or two into the semester, you will have most of those memorized anyways. So if you just go ahead and get started, that will speed up the process. I also have 2.4 listed there, figure 2.4 on page 34. And those are probably the most common units of measurement that we use. And they come from derived units. So it's a combination of different units, not just grams, but grams per liter. Not just centimeters, centimeters per liter, a centiliter. Which would be cc's, something we use for medicine. When they give you an injection, they give you cc's. Centiliters are what those are. Okay, so we are going to get into volume, which is page 35. So volume, basically, my definition for volume is something that takes up space. And you have, I tried to draw a lovely cube. I'm just going to shift this a little bit. I tried to draw a little lovely cube. It's not so lovely. Use your imagination. All right, so volume has a specific formula. We like to symbolize volume with a V, capital V, and it's length times width times height, LWH. And so for a cube, if each of those sides is a centimeter, that's where you would get a centimeter cubed. That is a measurement of volume. And so I have a dimensional analysis example below. If I have 100 centimeters in 1 meter, convert that to cubic meters. And then it gives you this volume for centimeters cubed. So start with what you're given. I have a cubic meter, okay, 1 meter cubed. So I'm going to start with the information I'm given. And then we use these derived units or these conversions that are given. They're always the same. And we can flip the top with the bottom. So if this is meters, I want to cancel meters out. So I want meters at the bottom, since this one is basically, it's like it's over top of a 1. Okay, so that will give me meters squared after this step. And how many centimeters are in 1 meter? I have 100 centimeters. And then we have to do that again because I still have meters to get rid of, right? I have 1 down, so I have meters squared at this point. And then if I take another meter out of that, I have 1 meter. So I have to do it 3 times to get rid of these meters. And then everything that's on the top I multiply, everything at the bottom I divide. So it's 1 times 100 times 100 times 100 divided by 1, which is multiplied by 1 times 1. Okay, so if you multiply these at the bottom and you multiply the top, then you can take that whole number and divide it by the bottom number. Okay, and we'll explain that in class. And that will give you 1 million centimeters cubed. Okay, I have in the red, it's just a side note, and it mostly applies for water, but 1 milliliter equals 1 centimeter cubed. So you can convert between liters and meters using this calculation. All right, I have our second set of notes. Density. Density is the ratio of mass to volume, and so I have the formula at the end. We're now on page 36. Sorry for the noise, construction. So we have mass over volume in green, and so density is usually a capital D. Sometimes it's a small d, and then you have mass divided by volume, or little m divided by big V. And then over here in orange, I have common density units. So sometimes we use grams per milliliter, or grams per centimeters cubed, or grams per liter. Occasionally, kilograms per meter cubed are used. This one's probably not as common as, these 3. All right, so we're going to practice a density problem. That way, we can do a density lab on Monday. Honors Chem, you'll do yours on Tuesday. All right, so what's the density of a block of marble that occupies 310 centimeters cubed? This decimal point here is not an accident, okay? It means that I have exactly measured 310 grams, okay? And it has a mass of 853 grams. So the best way to do this is to write out your givens and what you need to find. Okay, and I also have known versus what you don't know. So I know that it's asking me what's the density, so I can put my unknown over here. What do I know? I know the formula for density. I know that I have been told that the volume is 310 and the mass is 853. Okay, occupies, this terminology, you don't always have to write it, but that tells me how much space does this block of marble take up. That's a volume measurement, okay? And so these 3 dots in a triangle means therefore. So if occupies equals volume, then therefore I have volume equals 310, okay? Just a little of my shorthand again. So I have density equals mass over volume, my formula, and I'm looking for D, right? Density. So I just plug in my grams, my mass, over my centimeters cubed, my volume, and I plug that into my calculator, and I should get 2.75 grams per centimeters cubed. If you just write 2.75, you won't get full credit. Please, please, please make sure that you include units if you want to get full credit on problems, okay? So right now you're going to do number 2 on page 38. Complete this in your notes for me, please. And I will check that in class. Thank you. All right, this video will probably go a little over 10 minutes, but I do try to keep them at 10 minutes. We're going to cover dimensional analysis. This is something we're going to use all year long, and it will help you in math class as well as in science class. So it's a method to solve problems. You always want to start with what you know, what you've been given in your problem, okay? And then the goal is to convert to what you need. So my example, if I have 14 dozen eggs, I need to convert from dozen to single eggs, okay? So how many eggs do I actually have? So I want to write what I have been given, 14 dozen. This is what I know. Okay, it's not divided by known. I'm just underlining. That's what we know. I also have a conversion factor. And a conversion factor I have down here in the pinkishy purple color. These are known relationships between units. I have examples like 10 decimeters equals 1 meter. So therefore, I can put that in any relationship, top or bottom, because 1 meter will always have 10 decimeters. 0.1 meters equals 1 decimeter. And that dot, sorry, little error. And then 10 decimeters over 1 meter. So these two are flip-flopped. This equals the same thing, okay? It's just these are knowns. These are given. They're always the same, okay? If we had used centimeters, 1 centimeter is always 0.01 meters, okay? Or there's always 100 centimeters making up 1 meter, okay? So back up to our problem. A dozen eggs, 1 dozen equals 12 eggs. So I write it down in a fraction form, and 14 times 12 divided by, there's technically a 1 here, 1 times 1. So 14 times 12 divided by 1 equals how many eggs you've got. Okay, so if you've been practicing that, just following along, the answer is 168 eggs. Okay, so I want us to practice this now. So practice problem B is on page 39, and it kind of continues into 40. So it says express the length of 16.45, sorry, little decimal, in centimeters and in kilometers. So it's 2 steps. So I have to find 2 things. I'm going to jump down here, move us a little bit. I have to find centimeters and I have to find kilometers. So what do I know? What have I been given? I've been given a length, 16.45 meters. I know that 1 meter equals 100 centimeters, so those two relate to each other. I know that 1 kilometer equals 1,000 meters. These two relate to each other. So I have each step. You can either look at them one at a time. I start with what I know. I use my conversion factor, and I get my answer. Okay, so I'm gonna let you look at this for a little minute. You can pause the video, but then I want you to do number 2 from page 40. Complete that in your notes, and I will check that on our next class time. Email me if you have questions. I'm happy to help you guys. All right, see ya.